right?
Yes, sir.
And various patterns and rules applied while finding the squares of numbers, whether it's consecutive natural numbers or consecutive odd numbers, right, guys? Okay, I think we were done with the chapter, done with the square part, exercise 5.1. Okay, were you guys able to solve all the questions of exercise 5.1?
Yes, sir.
Emma, Emma, did you send all the questions or some of the questions solutions are missing, I guess, if
Some
I'm
of,
not wrong? Yeah,
sir, till question exercise, I guess so. Yes, I have finished all till 9, sir. I have
you've
taken finish.
sent all those questions, no?
Yes, sir.
I'm looking at your assignment right now. Okay. Did you had any problem in solving the questions?
No, sir.
Okay. And up to here you sent it. Okay. And what about you, Arhan? Yes,
Sir, I've
Arhan?
sent it. Sir, I've sent it.
Okay, okay. Yes. Today only I received multiple assignments from your sides from Arhan. Okay. You have sent
Yes, sir.
assignments of quadrilaterals, assignments from previous chapters as well. I've received today. Okay. Did you had problem in uploading it on the application?
Sir, my application isn't working right now.
Okay, okay. So
It,
that's why
I
I'm okay. That's why I'm
yes,
seeing
sir.
older assignments also here. Okay.
Yes, sir.
Anyways. Okay. So if the issue gets resolved here, so how we are going to do assignments here that in the classes I will attach you guys solutions. Okay. आपके solutions जो होंगे, I will attach them in the slides so that we will be able to discuss them in the class. Right, Ahmed and Arhan?
Okay, sir.
Yes,
Okay,
sir.
that will be
Okay,
better.
sir.
Right, guys? Okay.
Yes, sir.
So in the previous class, we discussed exercise 5.1, I guess, right? Okay.
Yes, sir.
Now let's move ahead. Right. See this Pythagorean triplets here. Did we discuss this one or not? I guess we discussed this one as well.
Yes, sir. It is good, sir.
Yes. So Pythagorean triplets are like this here. If you have got a right angle triangle here, okay, ABC. Okay, we know basically that square of hypotenuse is equal to square of base and its altitude, right, guys? So h square equals to b square plus a square. Okay, and basically these numbers here, h, b, and a, not h square, b square, and a square. H, b, and a, they are called as Pythagorean triplets, right, guys? Okay, so see here, if you take altitude to be 3 here, let's take it to be 4, and let's take it to be how much? Let's take it to be 5. So you will observe that 3 square equals to how much? Yes, 3 square is
Yes,
9
sir.
here, it is 16 here, and its square is 25. So 25, we know it is equals to how much? 9 plus 16. Okay, so basically these numbers, for example, these 3, 4, and 9, their collection is called as Pythagorean triplet. Triplet means 3 numbers. Similarly, you can have other numbers as well. That basically Pythagorean triplets, by this it means that the sum of square of 2 numbers will be equal to the square of third number, right, guys? So definitely you are going to take 2 smaller numbers and you will equate it to the square of largest number out of 3, right, guys?
Yes, sir.
Okay, so that is the thing
Yes,
with
sir.
it. Okay. So we represent them in the form of 2m, m square minus 1, and m square plus 1. And as I told you that the smallest number in the Pythagorean triplet will be 2m. Okay, it will be represented as 2m. The largest number will be m square plus 1. Note this thing very carefully. This will be the largest number. This one is the smallest number. Okay, and this is the number in between the smallest and largest. You can call it middle number. Okay. Okay. So solve example number 3 here. Just quickly solve this one and then we will move ahead and start square root today. Okay. Just let me blur the solution here. So you guys don't take the answers from here. All right. It's still visible by the way. Anyways, so you guys need to find a Pythagorean triplet in which one of the number is 12 here. Okay. So how we are going to find the numbers? First, we will equate 12 to 2m because the numbers are in the form of 2m, m square minus 1 and m square plus 1. So this 12 will either be in the form of 2m, m square minus 1 or m square plus 1. Isn't it, guys? Okay.
Yes.
So we will find which number is suiting for this 12. Okay, like आप पहले equate करेंगे 2m equals to 2, right? Or you will then equate it to m square minus 1 equals to 12. And then you will also try equating it with m square plus 1 and 12. And you will basically try to find out what is the in which case the value of m coming is a whole number. So 2m equals to 12 here. So m is how much here? It's going to be 6. And here m square gives me how much? 12 plus 1. Right, guys? That is how much? 13.
13.
So m square equals to 13. So under root 13, that will not give me a number in whole. That will not give a whole number. Right. So that is cancelled. So here it will be m square equals to 12 minus 1. That is 11. So m equals to root under 11. That will also not give me a whole number. So the number 12 will be represented as 2m equals to 12. Okay. So it is in the form of 2m. Right, guys? So now you guys have got m as 6 here. You can find out the other two numbers simply by putting this 6 in place of m. Right, guys? So quickly find out the other two numbers without looking at the solution given here. All right.
Okay.
Yes. And give your answers in the chat box. By the way, guys, do tell me if the screen resolution is the screen size perfectly visible to you guys or not. Is the resolution decreased? Is it reduced?
No, sir.
Okay, you guys don't have any trouble in seeing the screen, no?
No, sir. Also, I
Okay.
sent the answer.
Okay, okay,
No, sir.
okay. Send the assignment on this one. The name, the ID by with which I'm visible. This MD Sohail, Mohammed Sohail, not the whole Mohammed Sohail Khan.
Okay, sir.
Yeah. And after Eid, you guys will have a test. Okay. I will update you guys with the chapters from which questions are going to be. All right. It will be a live test in the class. Okay. Ahmed, you need to find the number, no? Other two numbers.
Okay, sir.
The number you have written here, it's basically 2m. Okay, so m is 6 here. Yes, Arhan. Got your answer. Ahmed, send your answer as well.
Sir, is it 4?
Yeah, that is correct, Arhan.
Okay, sir.
2m equals to 12. Guys need to find m square minus 1 equals to how much, and m square plus 1 equals to how much. And we have find out that m is equal to 6. Okay, Ahmed, just put the value of 6 in this one and in this one, and you will get the answer. Okay. Is that the first number? Is that the second number, Ahmed, which you have?
Yes, sir.
No. Look, first number is 12. For second number, that is m square minus 1. You are going to find it like this: 6 square minus 1. But how much is 6 square? Ahmed,
Yes, sir.
how much is 6 square?
6 where is sir at 12?
6 square, Ahmed.
Oh, 36, sir. 36.
So that is 36 minus 1, no? 35. So you assume 6 square as 12, then you did it like this: 12 minus 1. That's why your answer is coming 11. Okay.
Sorry, sir.
Okay, so we will move ahead then. Okay. Meanwhile, you need to send the third number as well. So, okay. See exercise 5.2. Okay. And you guys check if that is the number of questions given in your exercise, because the source from where I'm accessing this question, there are only 2 questions in that. Okay. But I have a little doubt that there are some more questions. Please check it, one of you. Yes,
Okay,
Ahmed.
sir.
Third number is correct. Very good. The required numbers were 12, 35, and 37. Right. These were the Pythagorean triplets. Okay. So square
Sir,
sum of 12 square.
in my book, there are 7 questions in exercise.
There are 7 questions, no?
Yeah,
No,
yes,
sorry,
sir.
sir. I was looking at the wrong chapter. Wait, let me check.
Okay. Recently, the NCERT textbook has been updated, right? So that's why some questions might be new. आप लोगों के हिस्ट्री के टेक्स्ट बुक्स चेंज हुए हैं, राइट? The syllabus have been updated.
Yes, sir. This has been updated.
Okay.
Square root is chapter number 6, sir, now.
Yeah. Square root is actually chapter number 6, but here it's chapter number 5, the source from where I have accessed that one, right?
Yes,
Okay.
sir.
Yes, Arhan,
Yes, sir. I had 2 questions already.
there are 2 questions only, no? Okay then.
Yes, sir.
So for these numbers also, you guys will be able to find the Pythagorean triplets, right?
Yes, sir.
Okay, and the first one is just find the square of the following numbers, right? And I've told you guys how to find them. Like for 86, you can write it 80 plus 6.
Plus 6.
It's whole square, right,
Yes,
guys?
sir.
So it will be 80 multiplied
Yes,
80
sir.
plus 6. Yes.
Is the answer 1024?
1024 for which one?
So the first one, first question.
For the first one. Yeah. So if you represent it like this, 30 plus 2, and then 30 multiplied 30 plus 2, and then 2 multiplied 30 plus 2. Okay, yes, in fact that is correct, 1024. We can check it like this, 900 plus 60 plus how much? 60 plus 4. So that gives you how much? 960 and 60 and 4. Yes, Ran, that is correct. Okay, Ahmed.
Yes, sir, I got it.
So that is the way how you guys need to find the square of larger numbers, right?
Okay, sir.
Okay. Now let's move ahead then. So today we are going to start the new concept in the chapter, that is square roots. All right, guys. Okay. Any idea about it before we talk about it? Like the numbers you have got, like 1 square equals to 1, 2
Sir,
square equals to 4. Yeah.
going roots of, to this of squares, like
Opposites of a square. Yeah. Let's say you have got 13 square. 13 square is how much? It's 169. 15 square is how much?
200 or
220.
225. What about 18 square?
um
How much it is?
sir,
Have you guys
160.
memorized up to 20 or not? It's 324. Okay. 19 square equals to how much?
19 squares at 192.
Ahmed, 19 square. Obviously, it is going to be greater than 18 square, no?
Yes, sir.
So that is 361. Okay.
Oh, sorry.
Now look at these numbers here. This 2 here, this 13 here, this 15 here, this 18 here, this 19 here. Okay. So upon multiplying these same numbers, like you multiplied 2 with itself, you multiplied 13 with itself, or you multiplied 15 with itself, you were getting the square of number, right?
Yes,
Okay.
sir.
So initially the number here, this 2 or this 13 or this 15 will be called as the square root of their square, right? So for example, if you have got 2 square equals to 4, in this case, what do we say? That square root of 4 is 2. Or you have got 15 square equals to 225, then we say that square root of 225 is 15 here. Okay. So that is basically your square root. It is basically the inverse operation of squaring, right? So here you are squaring the number. Okay. And in the square root, you are just inversing the operation of a square. To find the number with the given square is called the square number. To find the number with the given square is called square root. So for example, 2 square equals to 4. So the square root of 4 is 2. Or 10 square equals to 100. Therefore, square root of 100 is 10. Just reversing the process of squaring. Right, guys?
Yes, sir.
Okay. So square root is also of two types. Square root is also of two types. One is will be negative, one will be positive. Let's say I'm giving you a number 25. Okay. So 25 could be the square of 5. 25 could be the square, it could have been the square of 5 square, or it could have also been the square of minus 5, because 5 multiplied 5 and minus 5 multiplied minus 5 gives me same number 25, isn't it?
Yes, sir.
Okay, that is the thing here. So the
Yes, sir.
square root we are talking about, we have got a symbol to denote it. We identify the square root of any number by the symbol, this symbol here, and that is called a radical sign. Note this thing here. The square root of a number is denoted by a radical sign. that looks like this, right guys? That is called a radical sign. So say you have got number minus 16. So how do you read it? The square root
So
of 16 is
four square.
4. Okay, so we say here, yeah, the square root of 16 is 4. So this is how you will read it. If it is radical 16, you will read it like this: the square root of 16 is 4. Or if you have minus if you have 25, then you will read it as the square root of 25 is 5. Right guys? Okay.
Yes.
So and you guys will also notice this one thing, that that each perfect square has two square roots. One will be positive and one will be negative, as I told you guys moments ago. For example, this 25 will have two square roots. One will be 5 and one will be minus 5. Right guys?
Yes, sir.
Both 5 and minus 5 here are square roots of 25. Both are square roots of 25. All right. So here comes another concept called principal square root. What did I say? That's principal square root. All right. So you see this is symbol of a square root. That is a radical sign here. Okay. So see this thing. So I see principal square root. Principal square root. So see, as I said, a number, it's 25 here. There are two square roots of 25. One is a positive value, one is a negative value. So this positive square root of 25 will be called as principal square root. Yes, Aran, you're saying something? Hello?
No, sir.
Okay. So we say that this is, yeah. Yes. So you have got 25 and its squares are minus 5 and 5 as well. Okay. So we are talking about principal square root. Principal square root. You guys just give me a minute and let me connect my laptop to a charge, because it will turn off anytime. All right, guys. Am I visible to you guys or not?
Yes, sir. You.
Oh, okay, just give me a minute. All right. I will be back in a minute. Yeah. So I was talking about principal square root, right, guys?
Yes, sir.
Okay. So any number, like here we have got 225. Okay. So you see this sign of radical will only be used to represent only the square roots where you are getting a positive square root, right? Okay.
Yes, sir.
So principal square root, what is it? The symbol This is used to represent only this principle. Okay. Or
Yes, sir.
positive square root. Positive square root. Okay, meaning that when you write a root under 25, okay, so its answer is going to be 5 only here. Okay, it will not, this root under 25, this sign will not be used to represent -5, right guys?
Yes, sir.
So what if you have got a negative square root? What if you have got a negative square root of 25? Like this is a negative square root now. Then how do we represent it? Negative square root, and that is a positive square root. So what about this negative square root? How do we represent that one now? So that will be represented like this. So it will be represented like minus root under 25. Then you will get your answer as -5. Are you guys getting this thing or not?
Yes.
Okay, just let me repeat this thing here. Any given number can have a negative square root as well as a positive square root, like here -5 and 5. Okay, so for positive square roots, we will be denoting them like this, root under 25. Okay, but for negative square roots, we will denote them like this. There will be negative sign outside of the radical sign, right guys? And note one more thing here. There's a special case for 0. Special case for 0. Okay, so how do we write 0? Look, root under 0 is same as minus root under 0. That will give you the same number 0. So notice this thing here. All right. So root under 0 is same as minus root under 0. Okay. So whether you have got, so for 0, the square root can be both positive and negative. All right, guys. Are you guys getting this thing or not? So it can be written as root under 0 and minus root under 0 also. Okay. Okay. So let's move ahead then. Now now we are going to try to find out the number of digits in the square root of a number. Okay. So what I'm basically saying, 2 square equals to 4. The number of digit is 1 here. Number of digit is how much? It's 1 here. What about 13 square? It's 169. So number of digits were how many? Here 3. All right. For 40 square, it is how much? 1600. Number of digits are here 4. So let's say if the question is like this, that for any given square number, we need to find how many digits are there. How many digits are in the square root. So how do we find that? Okay. Just you guys give me a minute. It should be actually reversed since we're talking about the square root now. Yeah, it should be like this. In fact, look, it should be just reverse. So 4 is root under 4 equals to 2. Right, guys? So there's digit. How many digits are there? Only one digit here, right? Let's say let's say you have got 100, then it's 10. So number of digits here are 2. Let's see, you have got 225. That gives you how much? 15. So the number of digits here is 15. 2 here, right guys? Are you guys observing this thing or not? So we are basically trying to calculate how to find the number of digits in the square root of any given number. Okay, so let's say if you have got a perfect square number. a perfect square number with n digits, then the number of digits in its square root will be n upon 2. Okay, so say you have got a number perfect square here. Let's say take example of 9, that is 3. Okay, and the number of digits here is 1. So it could be simplified out by n upon 2 here, right guys?
Yes, sir.
Okay, and for, let's say you have got another example of root under 441. So square root of 441 is how much? 21. So how many digits were there? There were 2 digits in here. Okay, so here in this case, the number of digits are what? It is odd, no? Right? So what you will simply do here? You will simplify it like this: n plus 1 upon 2. That means 3 plus 1. Notice the number of digits: 1, 2, and 3 here. That is 3 plus 1 upon 2. That means 4 upon 2 equals to 2. So if the number of digits of the square is in odd, that is 3 here. So in order to find how many numbers, how many digits are going to be in its square, you will simplify it by the formula n plus 1 upon 2. That gives you 2 here. Right, guys? Or let's take another example. 1024. We know it's 32. The square root of this one is 32. So how many digits are here? 2 here. Right? So now
Yes, sir.
in this case, what is the number of digits of the square? It is an even. Yes, Ahmed?
Yes, sir.
The number of digits here are in even. How many digits are there? Here, 1, 2, 3, and 4. There are 4 digits here.
Yes, sir, they are
So it will be
they are
simply
even, sir.
represented by n upon 2. So that will be how much? 4 upon 2. Count the digits here: 1, 2, 3, and 4. So that means 2. So it basically says that the number of digits in its square root will be 2 here. Are you guys getting this thing or not?
Yes.
Look, let me just summarize it. Okay. If you have got a perfect square number, then the number of digits in its square root will be represented by n upon 2. All right.
Yes, sir.
And if you have got another number in which the number of digits are odd, like here you have 3 digits, so it will be represented like this: n plus 1 upon 2. And if the number of digits are even, that is 4 digits are here, then it will be simply written as n upon 2. So what we are basically trying to find out here? We are trying to find out number of digits in the square root of a number. All right, guys. So see, for example,
Yes, sir.
100 has 3 digits here, and its square root 10 has how many digits? It has 2 digits here. So how we find out this one for 100? You guys tell me. The square root of 100 is 10, and we know it has how many digits? We can see it has 2 digits here. So out of n upon 2 and n plus 1 upon 2, which formula we used here? Which formula we will be using here?
Sir, n
Like
upon 2.
n upon 2. Count the number of digits here. There are 3.
Oh,
So if you
So
take
n
n as
plus
3,
1, 2.
n plus 1 upon 2. All right, guys. So you guys will be using n plus 1 upon 2. Although the answer is already given here, that is 2. So if you check n plus 1 upon 2, n plus 1 upon 2, that will give me how much? What is the value of n, by the way, here?
Sir, 3.
3. Ahmed, where did this 3 came from?
sir, plus n is equals to 2. So 2 plus 1 is equals to 3, sir. The n
No,
value
no,
is
no. No, and basically here is the number of digits given in the number. How many digits are here? 1, 2, and 3. Look,
Oh,
this is what we are talking about. Okay. All right. Now see this one here. Estimating the square root of 247. If you are provided with any number, okay. Uh, if you're provided with any number here, 247, and you need to estimate where its square root, where the value of the square root is going to lie. So simply write 247 here. Okay, so 247 is clearly lying between 100 and what? 300 as well. But we need to take squares here, a square value. Okay, so it is lying between 400 and 100, right, guys? It is the square of 10 and it is the square of 20. So obviously 247 is lying somewhere between 100 and 400 here. Okay, so see here, is 247 not greater than 225 here?
Yes, sir.
225. And if you closely observe here that 256 here is much closer to 247 than 205. Look what I'm basically saying here. 10 is square, then 15 is square. Then you have got 247. Or it is 100, then 225. Then you have got 247. All right. Okay. Then after, what by the way, after 15 is square, okay, in between the square of which value this 247 is lying. Like if you take 16 square, it will give you how much? 256.
Oh, yes, sir.
Yeah. So this is 256 here. So 247 is lying closer to 225 or 256. Ahmed,
Sir,
256 obviously. Obviously it's 200 and it is obviously closer to 256.
yes,
So
sir.
we say that it is lying between square of 15 square and square of 16. It is lying between square of 15 and 16, this value 247. Okay, so obviously since it is lying more closer to 16, because 247 and 256, the difference here is only of 9, while here the difference is how much? It is 22. Okay, so the square root of 247 will be closer to 16 or approximately equal to 16, right, guys? So that's a rough way to calculate the square root of any given number. Therefore 247 is approximately equal to 16 here. Are you guys getting this or not? That's a very rough way to find the square root of a number. Okay, just find out between which two square the number is lying here. Like 247 was lying in between 225 and 256, right, guys?
yes, sir.
247 was lying in between 225 and 256. We see it is more closer to 256. So hence the square of 247 will be somewhere close to 16 square. Okay, so hence its square root will also be approximately equal to 16. Now let's have a more accurate method of finding the square root of any given number. Okay, see here, we have taken a number 36 here. Okay, now from this number 36, 36 is a square, and we need to find what is the square root of 36. All right, guys, finding a square root through repeated subtraction. So keep on subtracting odd numbers from it. Okay, keep on subtracting odd numbers from it. First subtract 1 from it, then subtract 3 from it, then subtract 5 from it, and keep on subtracting the odd consecutive odd numbers from 36 till you reach a value 0. Okay, so you will find out to reach a value 0, how many subtractions you did here. Total you did subtraction in 6 steps here: 1, 2, 3, 4, 5, and 6. All right, guys.
Yes.
Okay, see here. 36 minus 1, that gives you 35. Then again 35 minus 3, that gives you how much? 32. And then you keep on subtracting until you reach 0 here. So in how many steps you reach 0 here?
6, sir.
6. So 6 is the square root of the given number. Okay, I'm giving you guys one exercise. Find the square root of 25. Again, you will successively subtract consecutive odd numbers from it. Okay, like you will subtract 1, then 3, then 5, and 7, and so on until you reach 0. Ahmad, did you got this one?
Yes, sir. Kind of.
Okay.
So we will get 5 solutions.
Okay, but what is the step?
So we subtracted my odd numbers.
Okay, so that is 24. Then 24 minus 3, that is 21. Then 21 minus 5, that is 16. Then 16 minus 7, that is 9, right? Then 9 minus 9, that gives you 0. So how many steps are here, Ahmed? Count. In how many
Uh,
steps of subtraction we got 0?
5, sir. So 5 square.
Yeah, 5 is the square root. Is the square root of 25. All right. I want
Sir.
you guys to solve a similar one more question on the similar method. Find out about 64. Okay. Yes,
So there are 8 steps.
that is 8. Okay, so we subtracted the number consecutively from odd numbers 8 times. Okay, now that was the method of repeated subtraction. Okay, now another method is of long division method or prime factorization method. Okay, another method is of prime factorization method. Just give me a minute. Yes. So let's try to find out the square root of a number using prime factorization method. You guys know prime factorization, how it's done?
Yeah.
Okay. So let's say you have got a number here. Let's say to be 1764, right? And you need to
Yes, sir.
find the prime factorization of this number. So will you guys be able to do this, or shall I help you?
Can you help
Sir, I
us?
will.
Okay. Ahmed, look, you simply know. You just need to keep on dividing it.
Right.
Okay.
Okay. Okay.
It will be 882. Then again, it will be 441, and keep on dividing it further. Okay, just do tell me what
Okay,
is the
sir.
prime factorization you guys obtained. These two are
Sir,
no very
shall
simple methods. Yeah, you can send it
shall I tell it or send it
if it's possible. Just write it. Okay.
in the chat
Sir,
box?
coming in division.
Do I write
Yes,
it in
Ron.
the chat box?
Or just do one thing. Just tell me the answer.
So it will be 2 by 3
Yeah.
multiply by 3 multiply by 7.
Yes. Okay.
So
Ahmed,
we
did you
can
got
simply write it as
Sir,
2 square multiply by 3 square plus 7 multiply by 7 square.
2 square multiplied by 3 square multiplied by 7 square? Very good. Now, since we are now finding square root of 1764, right, guys? So these values will come under square root. 2 square, 3 square, and 7 square. And when you take numbers in the form of a square, under this radical sign, the square sign disappears. The square signs disappears. That means 2 multiplied 2 multiplied 3 minus 3 multiplied 7 multiplied 7. Okay. Now just write the pairs of numbers. Okay, just write the single numbers. So you have got 3 pairs here. So they are 2, 3, and 7. That is 2 multiplied 3 multiplied 7. That is how much? 42. Right. And let's complete this one also. Ahmed, this is it will be then divided by 3, and that will fetch you how much? 147. Right.
47.
Then it is.
Yes, sir. Can you repeat?
Yes, that is it. Okay. So in this, what we are basically doing, we first made pairs of similar numbers. We have made pairs of similar numbers. Okay. And you find it out the product of these prime factors, choosing one out of every pair. You have chosen one out of every pair here. You have chosen one out of every pair and just find out its product. That's how you get the square root using the prime factorization method. All right. So do one thing, find one using this method, find one more. All right, guys. Okay. So another number I'm giving you guys, let's take 6400. Okay. Find its value. Find the square root of 6400. That is pretty simpler. Simpler than the first one.
Yes, sir.
Sir, shall I write it in the chat box?
Yeah. Just write the answer in the chat box. Yes, Ahmed and Arhan.
Yes. Sir, the answer is coming in decimal, sir.
Decimal, that's not possible, no? The number is 6400. Notice there are even number of zeros in the end of the number. Okay, then definitely the answer is not going to be decimal. Okay, Arhan, that is correct.
That
No, Ahmed, that is not correct, because if you square the number 20, you get 400, not 6400, Ahmed. Okay, so look, be
Sir,
simply,
800.
it's 80, simply 80, not 800. Okay, so we can simply do it like this. You will divide the number by 2. Okay, then again by 2, again by 2, and 400, and again by, you can keep on dividing it with 2 until you reach to 100, and then 10 multiplied 10. Okay, or in just 2 steps you can do it. 6400, that is 800 here, right guys, and again 100, and this. Okay, so if you take this number here, 6400 equals to 8 multiplied 8 multiplied 10 multiplied 10. So what is root under 6400 going to be? You take out 1 out of every pair here. So there are 2 pairs here. So you take out 8 from here and you take 10 from here and obtain their product. That is 80 simply. Right, guys? So instead of doing the long calculation, you can find it out in fewer steps as well. Got this thing? Ahmed and Arhan. Ahmed, did you got this one? Arhan, your answer is correct, by the way.
Yes, right.
Okay, okay. Likewise, you
but I
can calculate
used
it
a
for.
different.
Yeah, you use the this one, and in fact you use is when smaller values. Okay, but we can find it using the uh, using few steps only. All right, guys. Okay, so after prime factorization, first we simply use the repeated subtraction. That is the first method, right, guys? Then we use the prime factorization. That was the second method. The third method is finding a square root by long division method. Okay, so that we will discuss in next class. Okay, so just quickly give me a glimpse of what you do in long division method. Okay, so let's see. If you are provided with a number, let's say it's 390625. Okay, that's a pretty big number. So for this number, how do you calculate? How do you find out the square root? Okay, so the whole step is in 5 or 6 steps. So I think that it won't be possible to discuss in today's class. So we will keep it for next class then. Right, guys?